Hello, let's look at the questions about KSP. So saturated calcium hydroxide solution. So that means it's at equilibrium, it's saturated, and that's what it is. Now you're adding hydrochloric acid, and we are supposed to use Le Chatelier principle and to explain the behavior of common ion and spectator ions, right? So it's a typical question. So let's see how to use the given example of calcium hydroxide and HCl to to explain the terminology basically, right? Now in any of these cases, what you want to do first, you want to figure out which one is the solubility product, the KSP, what's the sparingly soluble salt, right? So that you can check the data sheet and find out which one is a solid. Calcium hydroxide is the solid in this case, and break into ion, dissociate into ions, calcium 2 plus and hydroxide ions, right? Two of them. And then it goes back to precipitate. So that's the equilibrium. That's the saturated conditions, right? So that's the important thing to understand. So always I would figure out which one is the solid, which one is giving you KSP, and then you have to write the KSP equation, the expression formula like this way. And then you, whatever the next things you put it there. So in this case, HCl, it's fully dissociation, 100%, H plus and Cl minus, because it's a strong acid. By now we should know that. What Cl minus is a spectator. What is the spectator is actually first column metal ions, cations, sodium, potassium, lithiums, and so on, and also the anions of acids. So the chloride, NO3 minus, SO42 minus, kind of like that, right? Now H plus is not a common ion and not a spectator, right? So kind of weird thing, but we have to know H pluses are protons and these are part of the acids and they will do acid base chemistry, right? They are fast and they have a prominence, right? So let's see what can happen. So if you have H plus, it can join with OH and we make water liquid, right? Now that's the whole thing, because now even though it's not common ion, but it can react with the OH minus and make water, liquid water. So anytime if we're making a liquid or a solid, that will take out some of your ions. In this case, it will take out OH minus, and therefore, according to Le Chatelier, the missing OH will drive the shift to the right. So simply, you lose products and you go right to make the missing products. That's a simple way of LCP, Le Chatelier principle, I would explain. Anytime, actually, if you are losing ion products somehow, you are driving to the shift right. It's a shift right. That will increase the solubility. That's a common rule you can follow, right? If you want to increase the solubility, that the solid go into the ions, and that's what you want to do, right? Now this is a battle between the solubility and the precipitation, right? But we're going to do two different things to push it to the either side of the balance. Explain graphically what these Le Chatelier principle and what's the common ions and the changes coming to the equilibrium. So you need to show concentration against time in the x-axis, right? So what you have is you have a system at equilibrium, at saturation. So that would be flat lines for the cations and anions of the salt, right? So therefore, what happens, you will just start with flat lines for, in this case, magnesium 2 plus, and the hydroxide ions, these are flat. These are constant concentration for the time being because they were saturated, right? Now, at T1, you added H plus. So the chloride minus is neglected. And when you add the H plus, it will consume OH minus hydroxides. So therefore, hydroxide will suddenly go down, right? So that's a spike down, I would say. and then it'll back up slowly a little bit, but not to the level of the previous. So that's what we want to understand. Now, similarly, magnesium will be increased similarly, right? It's not exactly the same amount, a little bit increased. So therefore, when it reestablished the when it's reestablished the right, it will lose quickly and then back up a little bit, but not to the same scale, because hydroxide is twice and magnesium is one time, right? So it will indicate in this one. So it spikes up a little bit and it flattens out. So that's the re-establishment of the equilibrium, right? So that's how you understand this picture. We should notice that overall magnesium concentration is gone up from the previous level, and the hydroxide concentration is gone down from the previous level. So that's how most of the questions um, will be asked, and then I have an example later on. So once you forget about this one, we can try to answer that question. So look at this one. Show the common ion effect for the given equilibrium with respect to the given solution. So you are given a lead chloride at equilibrium at KSP, it is a saturated salt solution. What is the equilibrium given? Now we're going to add, so this is dissociation and the precipitation, it's dynamic equilibrium, right? They are equal rate at this point. Now we're going to add separately sodium chloride, lead nitrate, and silver nitrate. These could be solids or aqueous, doesn't really matter. So sodium chloride, 100% dissociation, you get sodium plus and chloride minus. Now, remember, first column metals are spectators. Just cross them out. Don't care about it. Now, chloride is a common ion in this case, right? The last time I said it's a spectator given that situation, but this one is a part of the common ion. So that means increasing chloride will shift to the left. Anytime ions are increased, it's a shift left. Remember that way. So that's how you memorize it, right? Let's keep it simple. So lead nitrate dissociate 100%, and the nitrates are cancelled because they are spectators. Nitrates and ammoniums also spectators most of the time. Now, lead plus. So the lead plus is part of the equilibrium. So you increase the lead plus, there's no difference between these two, and then it will shift to the left. Like I said, any ion increment will be shifting a left, right, of the equilibrium. So silver nitrate, nitrate is spectator. Silver plus, not part of anything here, but the silver plus will actually consume some chloride, right? Because silver chloride also precipitate. So like I mentioned, that is important. If you make some solids, silver chloride will precipitate, take out some of the chloride, and it's a different equilibrium, but it will definitely consume some of the chloride of our previous equilibrium, right? So that will make shift to right, because any losing of ions will shift to right. So that's how you make your cheat sheet, right?